All right. Hello, everyone. Welcome to today's UV webinar, Detection as Code, Engineering Faster, Smarter Threat Detections. Today, we're joined by Atif Ghauri, President and CEO of UltraViolet, and Jason Bertman, Head of Engineering. We appreciate you taking the time to join us.
To set things off, just really quick introduction so you know who you're talking to, what we do for UltraViolet. Well, first off, myself, I run our overall product technology and operations functions along with service delivery. And really the star of the show is sitting right next to me is Jason Bertman, who's the head of our R&D function, engineering, our DevOps capability, performing for all of our customers. So we're really fortunate to have him here with us as well to take you through it. And we'll jump into the agenda, but this is an exciting topic in the industry. Detection as code is really times vague, right? In that many companies call it different things. Gartner has terms for it. We'll take you through it. We'll get you smart on it. Security as a code, SOC as code. What does that mean in the industry? And more importantly, what does it mean for our customers? And as far as the agenda today, we'll go through that demystification of what it is first. We'll explain that, and then we'll illustrate it, right? So we'll through some pictures and visuals, we'll take you through how does it affect our clients and what is really the possibility for this as more and more companies adopt these concepts. And from there also, just like any great tech, there's challenges and pitfalls. And what are we seeing? What are we observing? And how that resonates with our customers and how we're helping them overcome some of the challenges related to deployment. So with that, I didn't give a chance Jason to say hello and just quickly introduce himself as well.
Sure. Hi, everyone. Good afternoon or good morning, depending on where you are, or good evening. Thank you for attending our webinar today. I'm Jason Bertman. I'm the head of engineering at UltraViolet Cyber. My background kind of runs the gamut from offense to defense. Started my career in the enterprise SOC in the public sector with around 250,000 endpoints. Kind of did the whole thing from detection engineering to incident response, forensics, and malware analysis. I then pivoted to red teaming and executed operations, exercises, pen tests in many areas of the public and private sectors. Like many offensive security professionals, I found my way into R&D at several cybersecurity agencies and started building instead of breaking. And I actually find that a lot of good pen testers can make very good software engineers.
And Jason, you still break.
Yes, it's a good thing, right? To stay frosty, right? Stay abreast of everything, right? Knowing where the skeletons are is half the battle, right? So that's why good pen testers make good engineers. These days at UltraViolet, our team's mission is really about building the next generation of what we call like defense powered by offense, right? And leveraging our experience to enable our teams to do their job better, faster, and with more accuracy, right? And that's me.
Awesome. Thank you, Jason. Yeah, and so with that, we'll jump into the agenda. So first thing, I wanted just a level set of who UltraViolet is. If this is the first time you're seeing us or talking with us, many of you folks, I recognize some names are some of our customers and some of our prospects as well as net new. But UltraViolet, we're a tech-enabled managed service provider, right? We are providing services to the federal government and of course commercial customers as well. We're based out of McLean, and believe it or not, we've been around for 20 years. Right? We've been around for quite some time with our legacy. We rebranded as UltraViolet Cyber in 2023, so hence the name and the coloring. But we've been around for many times. We're globally ranked. We have some close to about 400 employees across the U.S. and in India, where our global center is. And we are a responsive company to growth, right? We're not one of the companies that are just pumping money into the company and losing money. We're actually responsibly growing, and we're very proud of that and how we go to market, how we treat our employees, and how we, more importantly, how we treat our customers. And so that's a really important part of what we do as UltraViolet. And so a little bit about us to just understand level set. And then let's go into our topic, right? SOC-as-Code and detections as code. What does this mean? How is this impacting the marketplace? And Jason, I'll start with you to just start to talk us through and level set what is SOC-as-Code.
Yeah, sure. So I think one of the very first questions we need to answer is what is anything as code, right? What is having anything codified even by us, right? So first we should define what code is. And in our context, when it comes to the SOC, we usually mean either something like a data structure or a language that describes a state. What you see there is DSL, that stands for domain specific language, right? We describe a state, or we can mean code in a traditional sense, right? Like an automation or a script or something like that. Those are usually centered around automation. Kind of magical part about a state is that it's declarative, right? You are declaring to the system that you would like it to move toward that state. This creates something pretty special. It creates a source of truth for us. Any deviation from that truth we would consider to be erroneous, right? This is a source of truth, and you can use those principles of software engineering to help you define where that source of truth lives, right? So this also has a few side effects. This allows you to produce an audit trail, who committed what and when, and an accountability, right? Kind of who performed those changes and when they started to arise in the system, right? So that kind of has a side effect of allowing you to monitor the system as it moves along. This also gives us a place to apply the principles of software engineering to operations. That means things like approvals, reviews, version control, right? If something goes wrong, you roll back a version, right? Other systematic advantages also apply here. So any operation you might use in something like Git or other VCS, you can apply this to SOC operations, right? So what we're trying to do is essentially create a system where infrastructure as code meets security operations. We do this because our data needs grow, our customers needs grow, our response needs grow, and as those needs grow, our SOCs have to evolve to be more efficient, right? We have to introduce additional automation, additional error correction. So we use SOC-as-Code to introduce that scalable automation to do things like reduce alert fatigue. A lot of you are here, on behalf of that point. Increase our rate of response. We'll talk definitely a bit about that. And of course, minimize human errors, right? So we can use kind of that as a jumping off point to talk about how we solve that problem with UltraViolet's. And I think for that, I can pass it back to Atif.
Yeah. And so, now that we've covered what is SOC-as-Code, how do we look at it? Well, we'll go into how does Ultraviolet use this concept. So what we have, what we call Ultraviolet Lens, this is our cloud native microservices platform that where we apply for our MDR and SOC customers, these concepts of SOC-as-Code. One step back, I mean, looking across the industry, across our customers' tech stacks, we're seeing the shift left concept, where the lines between application and infrastructure are getting more and more blurry. So in this place, in this state, we want to get to a as a code mentality first. For what? For speed. And what this means is every procedure within our services, we ask, can we translate this into a repeatable, scalable, instant machine speed operation versus just a steady state type of manual operation? Now these operations all were triggered either by some flags from within our system or an execution by an analyst. And the rate at the data flow from our customers' infrastructures coming in is just, clearly too much for people to respond to. So along comes the machines to help us, right? And as we do this, I mean, what we're seeing the benefits for this is the repeatability across our SOPs, the scalability across using microservices with the partner like Amazon Web Services to help us scale up, scale down, which we'll talk more about. And then the speed at which it happens, like instant speed, done at machine speed. And all of that has influenced how we built this microservices platform through our legacy, through our, I mean, we've been at this close to 20 years. And as we've developed, and more recently in the past 5 years, this microservices platform, Ultraviolet Lens. And so, with that, we have some language around that, but what does it actually mean from a technical standpoint, right? So I mentioned the ability to fan up and fan down based on demand. And so there's a whole bunch of examples of microservices that you see listed here that we use as part of our operation. And these microservices can be triggered on demand and as needed based off of the response procedure that we're working on. And, all of this sounds interesting in theory. So, but what does it actually mean, right? So we want to try to illustrate this for you. So we have a more of a real world example to take you through of how we're using the UV-Lens platform, microservices based inventory to apply SOC-as-Code, detection as code. And so for this, we'll take you through an example of this. We have on the screen you'll see is a bunch of microservices, right? And so these arrows that you see on the screen here as we illustrate will go through and show you how we're going to use microservices in a real world use case. So one real world use case that everybody would understand is the ability to leverage their cloud security posture. So example here, into our system, into UltraViolet's, you could apply credentials for an Amazon account, a Google account, or Azure cloud. By simply taking those credentials, I'm going to walk you through a series of steps that our microservices take to show value and offer value, while we sleep, so to speak, with customers because of the ability for them to happen real time at machine speed. So in this example, you add your AWS credentials here, and then from there, a series of microservices are going to trigger. Now, these microservices are, there's many. I listed some out earlier. One of them, the Computer Information Security Standards, CIS benchmark, some of you guys may have heard of that, is an important benchmark because it looks at configuration recommendations, right? So we could trigger a CIS benchmark scan, and from there, that microservice running automatically on a repeatable time will determine misconfigurations, right? And configuration standards, and more importantly, in this case, hey, there's an open S3 bucket that doesn't have a password assigned to it. Bad news, right? You typically don't want to keep that even today. And so what can we actually do about that? So now that the microservice, the CIS benchmark service detected there's an open S3, there can be a scan done for all the buckets that may have that level of credential not included. And lo and behold, we do that secondary scan runs, and along comes the concept of response-as-Code. So wouldn't it be great if we just in real time added a credential to that open S3 bucket that someone accidentally didn't put a password on? Absolutely, right? And so what you see on the right here is an example of a configuration credential being applied to in real time at machine speed for that S3 bucket. And then it goes further, right? So from there, there's a whole bunch of microservices. I'm only using a few as an example here, but your mind can take you to other places, and feel free to throw out questions as you come about it. Next base is like enumeration resources, right? So looking at a service that will do that. And so we run that service, and okay, we'll do a port scan. It'll do a service enumeration. Okay, what other services are running on this virtual machine or on this device? And WordPress is running. And since WordPress is running, let's fire up a nuclei and a YAML scanner with the nuclei template to see what type of vulnerabilities is this WordPress version that we're running having a vulnerability. Oh, here we go. This actually has an AIOS vulnerability. And while this could be patched automatically, or however, for this specific vulnerability, we'll get into a human related update as detection as code. Because so there are absolutely some of the responses that we could do as code that are done using with humans. And of course, there's ones that we could use that we can automate. So in this case with WordPress, there's a generation of a Sigma tool. And so in UltraViolet, we have a license for Snap Attack. That's one of our partners, where we could pull based off of Sigma rules and apply and generate that Sigma rule. And you'll see an example here listed, and apply that into the platform. So then immediately, while we get this WordPress vulnerability patched, we have a detection if someone's trying to exploit it, so we could begin our defense and quarantine and countermeasures to protect that resource. So end to end here, starting with an S3 bucket that was open, going into a port scan, enumeration scan and finding that a service is running that's faulty, we're able to apply detection logic using Sigma code in almost real time fashion. In this case, with the human entering this one, but you could imagine other cases where we could apply a detection in real time based on the type of example that we're using. So that's a use case from end to end of this happening. And talking about what we see with our customers, there's also the possibilities of detection happening. We found a detection of someone that has exfiltrating large amounts of data. And based off of their signature, their host, their IP, we could determine, okay, well, you know what? Let's span up a whole cyber range for them, an area of a honeypot, effectively using a microservice based approach, where we quarantine them basically in a honeypot. And based off of that detection, they'll just continue to go down that other path. And the beauty of microservices to be able to do that on the fly and do that quickly, and then tear it down and clean up when you're done as well, as an active example of defense in a situation as such. So that's one example of detections as code running alongside the offensive side with the scanning and the vulnerability detection that we found through this example. And Kaylee and team will keep me posted if there's any questions that have popped up. But with that, I was going to pass to Jason next to go to another illustrative example of how we use detection engineering as code.
Yeah, let me actually go back one slide. I'm going to talk a little bit about our kind of what we do from the blue team perspective, and this is actually a great kind of segue where you were kind of mentioning there in terms of Sigma. What we kind of see here, like on this slide, is a typical workflow for what we do in from developing a detection in a vendor agnostic format. The Sigma is actually a very important technology to us. We leverage it pretty extensively, and it's at its core, a domain-specific language specifically for SIM detections, which we talk about in the bottom there. Now, this does allow us to develop detections in one place, right, and deploy those detections across either our stack or a customer stack. Whether we control the ingest or if we're co-managing it with a customer, we can deploy those detections directly to them. Now, one very important thing here is that you kind of mentioned there's two kind of modes of deployment or paradigms. Now, when you onboard directly with us, right, with UV, where we can control the ingest pipeline, this gives us a big leg up, right? This gives us an ability to actually skip the SIM. What do I mean by that, right? This allows us to really process events in real time. So our custom detection engine converts Sigma rules into native Python, which runs on our in-house developed stream alerting capability. And when you architect that correctly, which I'll say is a tricky thing to do, this can bring detection time down to seconds, and in some cases milliseconds, rather than minutes. So when we are developing those detections in Sigma, it also allows us to separate the ontology of a given log or detection, right, which is a big problem in the MSSP world and in the security operations world, from the actual detection logic. So you create the detection logic in the Sigma rule itself, then you standardize on that set of fields within the Sigma specification. Then you can transform the fields that are referenced in the Sigma rule to match the ontology of a given system. So we might have a mapping for the Open Cybersecurity Framework, or we might have a mapping for the Elastic Common Schema, or maybe we have a mapping that's specific to a customer's Splunk instance, right? It can vary across the board. And the point is that we don't have to change our detection logic. We just simply change the pipeline, right? So there's kind of trade-offs here and there, depending on where we're at. All of this can be stored as code and made auditable, reviewable, and automatable, right? So I guess with that, unless Atif has anything else to say on this detection as code slide, we could talk about how we can test those detections in a structured way, right? And that's the most important part here when you're talking about code, is that things have to be repeatable or automatable. Otherwise, you can't test them in a structured way. So let's use this opportunity to talk about the engineering piece of code, right? It's one to run the actual rule, but you also must be able to engineer the actual rule, right? And so the kind of core question we're trying to answer is, how can we have any confidence in our detections? And this is a question with many, many answers over the last 3 decades or longer, right? Since the 90s or 80s. One approach, which has been pretty common over the years, is to use an attack range, right? This has the benefit of being very easy to deploy. You have a set of known malicious logs that you play across your SIM. But this kind of also creates a problem that we call overfitness, right? You create a detection based on a known malicious log, and you don't know what the real log looks like as it fires across your systems. So detections are developed and validated against a static set of data. This presents an ongoing problem, right? So what do we do about that at UV? Now, doing it in attack range allows you to, it sort of captures detection's ability to consistently surface an alert, right? So it's not useless, but it doesn't represent a real life scenario, right? So the question becomes, how can we increase confidence in our detections while balancing the sort of dynamic nature of using various systems while we remain what we call deterministic, right, in our execution? And at UV, our answer to that is what you see in front of you, is to use adversary emulation to generate real logs in real time. So the reality is that systems have varying configurations, intricacies, right? Differences among them that we need to account for. So instead of replaying known malicious logs, what we do is we execute actions that are known to be used by adversaries. And we use our built-in system telemetry collection, and we have a proprietary UV agent that's for that, to feed those logs into our test systems, our fleet of test systems. We run those detections and we validate that the execute is expected, right? So this has a lot of follow-on advantages and benefits. This allows you to test both the logic itself, but as the log moves through your system, you must also normalize it with your ETL layer. You also have to craft a response, right? So this allows you to test the detection from end to end, not just the detection itself, but also your logging pipeline, also your response pipeline, right? So we get a lot of benefits out of that. And we really enjoy using these kind of adversary emulation frameworks, especially as an offensive security kind of focused company. We can kind of build in as part of our operations that feedback loop of executing that advanced professional tradecraft and detecting it on the other end. So with that, unless Tiff has anything, we can talk a bit about SOAR as it relates to SOC-as-Code. Now, SOAR playbooks are something that's been very popular for a while now, probably 10 to 15 years or so. In short, I'll kind of just talk about what they are and how they can be codified. And in short, they are a series of steps, right? That's all they are. And what we kind of see here is that they're applied on a given trigger, right? So something has to happen first before you can do something about it. Now, in real operations, triggers can be anything from a webhook, which is kind of something akin to what we might see in front of us, or maybe even a schedule, right? Something like that. In this case, we'll focus on events from external systems. So in this case, like a malware event, EDR, or a phishing email that's been detected, and reacting, right, to those events. So in the example of a phishing email, we might do things like check that sender reputation. We might analyze the attachments. We might update block lists, right? These are all sort of atomic actions that we might take in response to some upstream event. Now, in the example of an EDR, which is something you might see on the right side there, we might extract indicators from the system. We might actively quarantine devices, which we can do with a human in the loop as well. And we might modify metadata as it relates to the incident before we raise it up to the SOC and alert things like Slack, things like Jira, wherever we're kind of going as a destination system. Now, these kinds of things, what you'll kind of see as you look at SOARs are kind of this diverging series of logic nodes, right? You always see them as sort of a flowchart format, and there's a reason for that. We call it a directed acyclic graph. It's a DAG, which is essentially a series of steps from left to right, from top to down. They can be branching, they can come back together, but it's all kind of stored in this conditional logic. And those things can also be stored just as detections, just as adversary emulation. All of it can be stored in domain-specific language in a code base and reviewable, again, reviewable, auditable. This is what I'm going to hammer in. Reviewable, auditable, automatable, right? And those things can always be automatically applied, right? We are declaring a state for the system to move toward, right? So with that being said,
Jason, if I could jump in on this, yeah.
Please,
So,
yeah.
What we're seeing with customers specifically is that the SOAR use cases for and playbook development was really interesting and curious 2-3 years ago. And as companies started to roll it out, they realized they didn't have the ability to implement the steps that they wanted. and they felt that, okay, well, the software will just do it for me. But really, you need configurations for each of the steps, and then buy-in from the respective groups that are impacted by those steps. And that's really been the challenge when it comes to deployment of SOAR, in whether it's a SOC or whether it's in a response procedure related to a SOC operation. And so what what as code does for us is that some of those tasks are absolutely programmatic. And to Jason's point, they can follow a sequence where there's no human intervention required. And I think that's what's accelerating the use of SOAR now versus a couple years ago. Well, we'll jump ahead to our. I think this is our third use case, and then this probably maybe our final use case is just as far as going through the components, right, Jason?
Yeah, I think this is the last one.
Yeah.
Yeah. And you spoke to a great point there. I think we'll dive into it in the sort of pitfalls there. But you absolutely need buy-in from your SOC, right? There's kind of no way to skirt around that. Humans are still incredibly important to our systems, and there's just no way to skirt around that. So we'll talk about that in a bit, but it's a really important point to bring up for sure. So with that, we kind of want to talk about like how do we conquer this sort of proactive or retroactive analysis, right? So what we've covered so far is very much automatable, right? Things that we're doing on an ongoing basis, things that can be remediated on an ongoing basis. Sometimes there's a human in the loop, but there's sort of a big missing point that's been very popular in the last decade, and that's threat hunting. That still continues to see a lot of forward movement in terms of how it can be codified or automated. AI has been certainly a boon to some. You see lots of companies starting to utilize AI for both the enrichment and ongoing remediation of cases, but also in this threat hunting category. They're using it to do things like construct queries, do like sort of interesting things that are specific to systems, perform data analysis. Any of you that have used or those upstream AI providers have seen them generate graphs, have seen them perform analysis on things like CSVs and JSON. They can do actual code analysis, right? So we're really starting to see the advent of ML and AI kind of make its way into threat hunting over the last several years. And it's an exciting thing to have because, as we mentioned, SOCs need to evolve. Our data needs continue to grow. If anything, we're capturing more data now than we have ever, right? The advent of the movement to cloud didn't rid us of our data needs. It only made it a lot worse, right? So a common problem to have when it comes to threat hunting is people external to their analysis being able to reproduce their results. This is something we see quite a bit. You come out of a hunt with a conclusion and you want to know how they got there, right? So they kind of make a write-up for it, they submit it, and it gets reviewed, and it's a very human process, right? And that's okay. That works well, but there's better ways to go about it. And one solution to that problem is to use interactive, sort of self-documenting notebook, right? And Jupyter notebooks are a very popular solution to that. The runtime is not locked to Python. It doesn't have to be a Jupyter notebook. It can be anything that we like. But we do find that just based on our speaking with our SOCs and our personnel, Python is the most accessible language, and it's something that a lot of people can easily learn how to use, right? So that kind of allows threat hunters to run real-time code, right? Real-time analysis, save off that analysis, we'll talk about that in a sec, and create an audit trail, right? So if you've ever used a Jupyter notebook, it's a series of steps, kind of similar to SOAR, in fact, but it's a documented notebook, right? I took this step, and then this step, and then this step. And it creates an audit trail of performed actions and kind of shows you how they arrived at their conclusion. Now, from the SOC-as-Code perspective, we can front load notebooks, right? So we can introduce libraries and templates and tools to make that process of threat hunting easier, right? So if we want threat hunters to easily be able to load from our data lake, then we provide tools and libraries to do that with, one or two lines of code, something easy and repeatable, click, point, and you've got your data, right? Like you want to make the process of threat hunting as easy as possible. The deployment of those notebooks can also be automated in CI/CD. So as you introduce libraries and tools, you actually need to rebuild the runtime so that your clients, your threat hunters, your analysts have access to those libraries and tools and templates. So you need to maintain again, automatable, accountable, reproducible set of notebooks that they can use to work toward their conclusions, right? But that's the front loading. We can also offload or save off the results of those analyses for after action review or reproduction, right? So once a threat analyst has or a threat hunter has completed their analysis, they come to a conclusion, and you can read it from top down. That stuff is committed to a code repository. You can have it be reviewed by other analysts. You can have it be approved, merged to a historical review repository, referenced by ticketing and automation and things like that. So that means that other analysts, if you've ever committed a Jupyter notebook to a code repository, the visualizations are actually rendered in your code repository. So you don't even need to run the notebook. You can just have your incident manager go and review it and ensure that you followed a sensible paradigm, right? So this is a really, really good boon to threat hunters, but also to incident managers as well. It lets them double check the methodology, see how threat hunters arrived at their conclusions, all of that kind of stuff. Anything you want to add there, Tiff? Before we jump into kind of the precautionary measures we can take when we talk about SOC-as-Code?
Yeah, let's do that, and we're monitoring the Q&A here, and we've been incorporating some of the responses that you guys asked for. But if there's still questions, continue to add into the chat. Hey, Jason, take us through the promise and the peril. What does Darth Vader think of all this? What's the danger?
Yeah, it's not an easy system, right? It's easy to think like that it's a magical, like silver bullet answer to all your problems as a SOC, right? We have to operate at very high speeds. We have to recover from errors very quickly. It's not an easy thing to do. We face incidents every day where things happen with our systems, right? It's just a fact of life. So when you introduce automation, when you introduce the kind of structure, it certainly has benefits, right? It makes you faster, it makes you more efficient, it makes things reviewable and auditable, and those things are really, really great. But there's also some challenges, right, that we have to face as we go on. So when we're designing things like detections and playbooks and policies, to what you spoke to, Atif, right, when we're taking action on customer machines, the axiom is always garbage in, garbage out, right? We'll always, if we have content that is not good, we'll always get bad outputs, period. There's no other way to go about it, right? So we need to kind of introduce as part of our continuous validation process, we need to be okay with cutting things loose. When things are noisy, tuning them only gets you so far, right? You can tune out the noise, but maybe your detection isn't so good, and that's okay, right? So we need to kind of carve out time to engineer detections properly, right? Sometimes it is very much a content issue. Sometimes it is very much a playbook issue. If things are loud and noisy, suffering in silence or suffering through your operations, your incidents, is not the answer, right? It takes a continuous improvement process as part of this. And so it's always an ongoing process to make sure your SOC-as-Code operation is working as you intend. The other side of it is that as we add on more and more to the system, right? We talked a lot about kind of declaring a state and having the system move toward it and hand waved away all of the other parts that make that possible. That's a very complex system. And the truth is that complex things fail in complex ways, right? This is something that if you've worked in software engineering, it's just something that happens again and again and again, right? And more often than not, complex things can be attractive, right? You might look at something and think, "Ooh, that looks really interesting," or "that looks really useful," when the truth is that thing is very complex. And as a side effect to something being complex, you also need to be very diligent about how you manage your infrastructure, how you manage your integrations, how you manage your monitoring. I think we have something that we say quite a bit on the platform team. You can't manage what you can't measure, right? And so you have to be able to manage or you have to be able to measure everything in order to manage it effectively, right? So if you have a complex system, and guess what, you probably do at this point, you need to be able to measure it well so that you can react accordingly. One of the other things that you mentioned, Atif, was kind of that acceptance, right? Like as we've gone through this, we need to kind of face the fact that adapting the SOC to software is neither straightforward nor easy, right? It's not something that is that happens overnight, and you need the SOC buy-in. You need people to be there for that setup. Often, what we see in software engineering teams is a big disconnect between what is built and what is actually needed, right? So it's one thing to have the system; it's another to set it up in the way that the SOC actually needs it. Every team is different. Every client is different. Now, in platform, our clients, our first client is the SOC, right? Like they give our clients what they need. And so everything kind of has to have a center around their workflow. And that's really important when you're designing or architecting any system for this. Speaking a bit to you can't manage what you can't measure, right? You need to be able to detect errors when things are going sideways or not reacting in a way that you expect, and to be able to correct them. And that's obviously a great opportunity to use those software engineering principles. If something falls outside or is erroneous in that state, or kind of exits the norm, right? And this gets a bit about data analysis and monitoring, right? Just because you are not maybe you're receiving too many alerts, maybe you're not receiving enough alerts, right? And sometimes that's a sign of a healthy system, right? Other times it's not, but either way you need to know, right? So we use a concept of error detection, and you might use statistics, right? Something thrown out there, you might say like P95, right? Something is outside of a given band, or something that you're used to, or standard deviation away, or something like that. You might say, hey, this is outside the realm of our expected throughput. And so even though nothing is throwing an error, we should investigate, right? So you need to be able to get in there and understand whether or not something might be wrong, and not necessarily if something is wrong. It's a really important paradigm there. And our last point is to make sure that we understand, right? As we continue to like build in ML and AI and all these fancy solutions, at the end of the day, like our people are still the most important part of this. We can make their jobs easier, but it's also our job in terms of building for them to be able to balance automation with human expertise. Humans have to be in the loop. They have to make the right decision, the smart decision. We can't always trust the machine, at least not yet. Anything else you want to add on to there? That's it.
Yeah, I think that's the whole thing, is that we as soon as we get the customer to go move ahead with the approval, there's a lot of caution that we see with our customer base as to, okay, well, are we actually going to have an automated solution, an automated bot do that for us, and what's that impact going to be? So interesting times ahead. Our contact information is available here as well to continue the conversation on SOC-as-Code, detection as code, and how to incorporate this into your environments. And maybe Kaylee, I'll pass over to you to close us out.
Like Atif said, if any questions do come up to mind after the session, feel free to reach out. We're always here to help. You can connect with us on LinkedIn, on our website, or via email. And so on behalf of everyone, thank you again. We look forward to continuing the conversation.
Thanks. Thanks for having us, guys.
Thanks, everyone.